So here, this means the nth term equals a sub 1 is the first term. Okay, so here the first term is 2. Here the first term is 1. The first term can be 563. It can be negative 1/2. It can be anything. Okay, the first term does not have to be 0 or 1, anything like that. It can be anything. Then n in both of these is the number of terms. So if you want the 5th term, n is going to be 5. If you are given the 8th term, then n is 8. If you want to find the 400th term, then n is 400. And then again, d is the common difference. If you can't look at that, okay, when you look at that and you don't know what the common difference is, and maybe that one's easy, but maybe they aren't all that easy. You take the second term minus the first, and then so forth. So 6 minus 2, 10 minus 6, 14 minus 10, 18 minus 14. That's how you get the common difference if, when you first look at it, you can't tell. Also, if you're trying to find the common difference, you're trying to determine if it's arithmetic. That's what you do in order to determine whether it's arithmetic or not. And then for the common ratio, if you can't figure out what it is, you take the second term, divide it by the first. Third divided by the second. Fourth divided by the third. Fifth divided by the fourth, and so forth. You can do that forever. If it tells you it's arithmetic or geometric, you only have to do that once. If it asks you, is it arithmetic or geometric, you have to test the whole sequence that's given. Because maybe the first two have a difference of 4, but then the next one has a difference of 5. That makes it no longer arithmetic. And then again, just as far as wording goes, if we say a sub 5 equals 12, that means the 5th term is equal to 12. This is what the value is of the 5th term in that particular sequence. Okay, so today these are called explicit formulas or explicit definitions, and then tomorrow will be recursive. So there'll be a difference between today and tomorrow. So these first examples ask you to find the first 4 terms, and then is it arithmetic, is it geometric, or is it neither one of those? So what you do is this is the nth term. Okay, that's the formula. We're going to ask you to find the nth term. That's it, because we can find whatever term we want. 100, 4,000, 5 million, or just 1, 2, 3, and 4. So we just plug in 1 for n. So this is 5 times 1 plus 2. 5 times 2 plus 2. Now, I don't have to see you plugging that in. If you can just look at it and come up with 7, that's fine. Come up with 12, that's fine. 5 times 3 plus 2, and 5 times 4 plus 2. So there are the first 4 terms. Then, is it arithmetic, geometric, or neither? So is there a common difference, a common ratio, or is there neither one of those? Well, hopefully we can look at that pretty easy and see that we're adding 5 each time. So this would be an arithmetic sequence. All right, the next one, again, if you don't have to show the work and you just come up with the first, second, third, and fourth term, that's fine. I'm going to show it. So we have 1 plus 1 over 1 plus 2. Since it's the first term, I'm plugging in 1 for n. So I get 2 thirds. 2 plus 1 over 2 plus 2. 3 fourths. 3 plus 1 over 3 plus 2. 4 fifths. 4 plus 1 over 4 plus 2. 5 over 6. So there are your first 4 terms. If you want to write them like a sequence, you can do 2 thirds, comma, 3 fourths, comma, 4 fifths, comma, 5 6, comma, that's fine, but you don't have to. And then, is it arithmetic, geometric, or neither? Well, hopefully, arithmetic, we can kind of tell. The denominator is 3, 4, 5, 6. So we've got to get a common denominator for all of those and figure that out. So we can hopefully see very easily that is not arithmetic. We can't add something to each of those to get to the next. But geometric is sometimes a little trickier because you have to multiply by something. So if you can't just recognize whether it is or isn't geometric or neither, we do this. Take the second term divided by the first term and then keep going. Because again, when you're determining something, you can't just determine something. 2 numbers don't make a pattern. Okay, you have to have at least 3 for there to be a pattern. And since we have 4, If we check these two and it's the same, we check these two and the same, we have to check those two to see if it's the same. Once it's different, we can stop. But if it's the same, we have to check all the numbers that we are given. So by check, we're going to do 3/4 divided by 2/3. Second minus first. We can't divide fractions, so 3/4 times 3/2 is 9/8. So that's the common difference going from 1 to 2. So now we need to go 2 to 3. So we do the third divided by the second. Can't divide fractions. 4/5 times 4/3. We get 16 over 15. That is not the same. So this one is neither. It is not geometric or arithmetic because there is not a common difference or a common ratio. I wouldn't expect any work on that, arithmetic, okay? So here, on these problems right here, I wouldn't expect anything. Fine if you want to show it, but that is not, I wouldn't even expect to see that because I think you can do that in your head as well. All right, a sub 1, so that's 3 to the first. 3 to the second, 3 to the third, and again, I don't have to see the 3 to the third. I would just want to see 27, 3 to the fourth, 81. So you look at that, maybe you can tell that there is some kind of pattern. It's not adding. 3 plus 6 is 9, 9 plus 6 is not 27, so it's not arithmetic. But we can check. 9 divided by 3, 27 divided by 9, 81 divided by 27. All of those, or what did I do to 3 to get 9, 9 to get 27, 27 to get 81. I did the same thing. I multiplied by 3. So there's the first 4 terms, and then this is geometric. So just because you multiply or add or subtract or divide doesn't necessarily mean it is arithmetic or geometric. You have to check if it asks. All right, so this one is 1 to the third, 2 to the third, 3 to the third, 4 to the third. So 1 plus 7, 8 plus 7 is not 27, so it's not arithmetic. 8 divided by 1, 27 divided by 8, or 1 times 8 is 8. 8 times 8 is not 27. So we know it's not geometric, so this one is neither as well. 8 can still be a sequence, it's just not geometric or arithmetic.
Do you just have to go to 4 terms? Like, will you be able to tell at that point?
Because it says, state the first 4 terms.
So, like, will you be able to tell at that point if it's 1 or 2?
Oh, yes. If we give you something like, yes, I see what you're saying. Absolutely. Okay, we won't, like, just give you these and then you have to keep testing. Okay, whatever we give you, we expect you to test all of those, but you don't have to test past what we give you. Good question. Okay. All right, so the next kind. Now there's a lot of examples today just because there's a lot of different ways these problems can be asked. Okay, you have being able to have that formula and have all these 1, 2, 3, 4 different variables. Okay, you can be given any combination of those variables and be asked a question and have to find something. So this one asks for the nth term and the 10th term. So the nth term is just the formula. Okay, it's going to have a variable still in it. So the nth term is a sub n. We want to know what the nth term equals. Well, the first term, it tells us, is 2. N is going to be the variable. It tells us the common difference is 5. Now, I do expect you to distribute and combine like terms, just like I always do. Okay, that will be an expectation. So the nth term, 5n minus 3. Or negative 3 plus 5n. I don't care what order that's in, but there's your nth term. So the nth term is figure out what a sub n equals. It's going to be some kind of formula / definition, however you want to say that. Then once we find the nth term, we can find any term. I do not want you, adding 5 10 times. Okay? I don't want you to say 2 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5. That is not what we want you to do. Could you get credit for the answer? Maybe a point or two. If it's 10 points, you might get 1 or 2 points. So do not do that. Okay? We want you to use the formulas, because if not, we're just going to keep making the bigger. If we notice people are just adding to get the answer, you're not doing it right, then we're going to make the numbers so big that you have to use 3 pieces of paper to add all the numbers, and then you're going to make a mistake, and then you're going to run out of time, and you've done 1 problem out of 20, okay? So just use the formulas, and then we don't have to make the numbers that big, okay? Use the formulas. So a sub 10 is equal to, now I don't even have to see this work. Y'all could probably figure out what a sub 10 is without plugging this in, but I'm going to do that. So 5 times 10 minus 3. So a sub 10 equals 47. Okay. Again, this I wouldn't even have to see. I'd want to see one of these 2 steps. And sometimes the D, you'll see the D out in front. That's okay too. It's the same thing. Whether you distribute the D from the front of the parentheses or the back, you're still going to distribute it to everything. Okay? So if you see a sub n equals a sub 1, or just a, D times n minus 1, it's the exact same thing. It's just multiplying from the front instead of the back, but it gives you the same result. All right, same problem, just different numbers. A sub n equals 3 plus n minus 1 times negative 4. Now, if I don't put those parentheses, that becomes minus 4. Even when you write it down, you see minus 4, you're going to subtract instead of multiply. So whenever you have negatives, be sure to use parentheses. So negative 4 times n is minus 4n. Negative 4 times negative 1 is plus 4. So a sub n equals 7 minus 4n. And again, I don't care. I usually like to put the positive value first, but it doesn't matter. Okay, negative 4n plus 7 is exactly the same equation. It does not matter the order. And then the 10th term, 7 minus 4 times 10. So a sub 10 equals negative 33. And hopefully that makes sense. I mean, if you're given the first term and that the difference, meaning every term goes down by 4, you should know your answer will be negative. Okay, it should be negative. Now this one, same problem, you just have to think, not very hard, okay, but just a little bit. What is the first term? You just have to look. It just doesn't tell you. You have to know where the first term is located. It is actually located first. Whatever is first is the first term. It is physically the first number in the sequence. The difference, we've got to figure out. We can look at that very easily and figure out that that is plus 3. So a sub n equals 1, n minus 1 times 3. Be sure, I don't want to take a point or 2 off every time you don't distribute and combine like terms. Okay? Distribute, combine like terms, 3n minus 2. There's your answer. If it asks for the 52nd term, we can plug in 52. We don't have to count or add 3, 52, 50, 47 more times. Okay? You just plug it into the formula and you could find your answer from there. Especially when the numbers like find the 4,000th term. Okay, you do not want to add 3 44,997 more times to get that answer. Use the formula. Same thing. A sub n equals the first term is actually where the first term is located, 13. N minus 1, we've just got to figure out the difference. So what are you doing to get to the next term? Or second minus first, third minus second, fourth minus third, you get negative 6. It's going down, so the difference is minus. So the nth term, 13 minus 6n plus 6. The nth term is 19 minus 6n, or negative 6n plus 19. Again, I do not care what order. One thing, can n ever be a negative number? No. Can it be a decimal? No. Okay. It's going to be first, second, third. Okay, it's going to go from there. So n must be a positive number. So positive whole number, positive integer. Think of it that way. A sub n, A sub 1, d, that can be anything. But n is going to be a nice whole number for you. Okay, nice positive number. Now this one, very easy still. Okay, it tells us, again, it's arithmetic. So we don't even have to guess. We know it's arithmetic. So we don't have to test to see whether it's arithmetic or not, like that first example we did. It tells you it's arithmetic. So always read the directions because they are very helpful. We know it's arithmetic. Now what I would do on this one is get everything to have a common denominator. That way it's a lot easier to see. You don't have to. So I see these 3's and 6's. I would make this 14 over 6, 11 over 6, 8 over 6, 5 over 6. And now look how easy that is to determine the difference. We're subtracting 3, 3, 3. Now we're not just subtracting 3, 3 over 6. So our difference is negative 3 over 6 because 11 over 6 minus 14 over 6 is negative 3 over 6. Now we always want to simplify, but on this one I'm going to simplify at the end because remember I'm going to have to distribute and combine like terms. So I'm going to end up having to get a common denominator anyway, so I might as well just keep those 6's until the end. So the nth term is equal to, again, I'm just using my common denominator that I already did over there. Doesn't matter if you use 7 over 3 and negative 1/2, but then you're going to get a common denominator of 6 anyway before you combine them. So plus n minus 1 times negative 3 over 6. So a sub n equals 14 over 6 minus 3 over 6n plus 3 over 6. So now notice you already have a common denominator, and then you can just simplify the 3 over 6. So 14 and 3 is 17 over 6, 3 over 6. Now I can simplify that to 1/2 n. And there's your nth term. So don't associate fractions with geometric, okay? Especially if it tells you. If it says, is it? Figure out if there's a common difference or a common ratio. Common difference is second minus first, third minus second, and so forth. Common ratio, second divided by first, third divided by second, and so on. But if it tells you, you don't have to do all that testing. Test one, and then you know what the common difference or ratio is.
Would it make a difference if you said negative 1/2 n plus 17?
No. Anything else so far? All right, here's another one. So this one, what we have to first figure out is what all do we have and what do we need, okay? We need the 1,000th term. So if we plug in 1,000 right there, we don't know the difference, we don't know the first term, so, and we need to know this term. So we got to, that 1,000 is going to have to wait. We know that a sub 11 is 52. We know that a sub 19 is 92. So our numbers are increasing. So we know our D is going to be positive. We know that much, right? Because it's increasing. From 11th term, 52, 19th term, 92. So there are lots of, I've done this problem at least 3 different ways, and I'm sure there's even more after that. I'm going to show you the way I think is the easiest. So if I know the difference between the number of terms is 8, and the numbers between those 8 terms is 40, what would our difference be? 5. 5 numbers per term, between each term, okay? Versus setting up a big ugly system and having to multiply by a big number, distributing, doing all that. That's one way to do it. Setting up a system, there's no need to do that big system, okay? All you got to do is look at it. All right, so now we know D. Well, we still need to figure out what the first term is before we figure out the 1,000th term. Because we know D, we know N is going to be 1,000, but we need this in order to find that. So I know that D is 5. Okay? So remember, I'm looking for this right here. So I have to use the information given to fill these in. I know the 11th term is 52 and the 19th term is 92. So I can use either one of those sets of information. I'm going to use this one. So if I use that information, I know that the 11th term is equal to 52. So 52 is equal to a sub 1. I know 52 is the 11th term minus 5. So I have to use that information to find the first term, and then I can find the 1,000th term. I could have said 92 is the 19th term. That would have worked also. So now I have 52 equals a sub 1, 10 times 5 plus 50. So a sub 1 is equal to 2. So now I have enough information. Now I'm going to find the nth term just because I think it's easy to plug into that formula. We don't have to find the nth term. We only need the 1,000th. But if I say a sub n equals 2 plus n minus 1 times 5, I can say a sub n equals 2 plus 5n minus 5, and a sub n equals 5n minus 3. Okay? So now that I know the nth term, I can find the 1,000th term. Whatever they asked, I could find. So a sub 1,000 is equal to 5 times 1,000 minus 3. So a sub 1,000 is equal to 4,997. Now, once you found a sub 1 right here, you could have said a sub 1,000 equals 2 plus what do we know? 1,000 minus 1 times 5, and then done the work from there. That would have worked also. Okay? Instead of finding the nth term, because this one didn't ask for the nth term, once you had your a sub 1 and your d and your n, you could just plug those in to the formula right there. Now, that's doing 999 times 5. Maybe you don't know what 999 times 5 is off the top of your head. Oh, yeah, you could have done that also. That's even number 4, fourth way for today. So far, there's 4 ways to do this problem. Or, and even within the problem, there's different ways to go about it. So absolutely, there are different ways to go about it. Okay? I kind of like the reason I show you the mathematical way, because some of them are really easy to see, and some of them aren't so easy. So if you have the algebraic way, the ones that aren't as apparent, or not everybody can see patterns that well, okay? If you're really good, like you have a lot of number sense, these patterns are probably easy. If they're not so easy, then just do the steps. But lots and lots of different ways to go about doing these. All right, even another way. This one gives us the first term and this 115, and it wants to know how many are there. Again, I don't want to see all those numbers in between written down. I want you to use the formula. So we know that the term we're looking for is equal to 115, but we don't know what number it is. That's what we're looking for. Which term? We know the first term right here. What is actually first is 3. N's what we're looking for. And we can figure out the difference. 3, 5, 7. So the common difference is plus 2. And now we just solve for n. 5 equals 3 plus 2n minus 2. So 2n equals 114. So n equals 57. So once you know what to do, just kind of like the last unit, once you knew what to do, then it was just a lot of math. If you didn't know what to do and didn't get to the add, subtract, multiply, divide, common denominator, it was difficult. But once you know what to do and you get that part written down, that's the most important part. The algebra should be the easy part. Okay, plug in, distribute, subtract, divide. That's all we did right there. Or subtract, and then we divided. All right, geometric. So now it's telling you it's geometric. Now geometric is important to know PEMDAS. Some of you still struggle a little bit with PEMDAS because you just want to work left to right, and you cannot work left to right necessarily. Sometimes you can, but PEMDAS is important. Notice there's some multiply here, but there's also an exponent. An exponent comes before multiply. So we can't multiply A1 times R together and raise that to the n minus 1. That's not true. We can't work left to right on this. We have to raise the ratio to the n minus 1 and then multiply by the first term. So here, a sub n equals the first term, which is 3. Now, I would suggest always putting r in parentheses because if r is either a fraction or a negative number, it has to be in parentheses. Or order of operations is different. Your spirals all year have had that -2 squared versus -2 quantity squared, right? We've been talking about that all year. Same thing here. If you don't put parentheses around something, it changes. So to the n minus 1, there's your answer. Nth term. No distributing or combining like terms. You just have them, plug them in, and there it is. Now if we're finding the fourth term, 3 times 2 to the 4 minus 1. Not 6 to the third. That is very different. 2 to the third times 3. You can't pick the order, PEMDAS. So 3 times 2 to the third. 3 times 8, 24. Now, do I have to see all this work? Absolutely not. Okay? Do not have to see you plugging all that in. If you want to, please do. If you had written this 3 times 2 to the n minus 1, again, that would be okay. But my suggestion would be always use parentheses. That way you don't forget when it's a fraction or a negative. Right? A sub n equals 5, 1/2 to the n minus 1. There's your nth term. All you need to know is your first term and your common ratio, or your first term and your common difference if it's arithmetic. So then the fourth term, 5 times 1/2 to the 4 minus 1. So 5, 1/2. So 1 to the third, 2 to the third. That goes to both of them. 1 to the third is 1, 2 to the third is 8. 5/8 is your answer. Like the arithmetic, okay, instead of just saying A equals this and R equals this, you just have to figure out what it is, which is not difficult. Okay, A sub n equals the first term. Actually, what is the first term? Nothing tricky about that. First term is 8 times something to the n minus 1. So you can look at it. What happens? What do we do to 8 to get to 4, 4 to get to 2? We divide by 2. But divide by 2 is not a thing. Okay, that's not something you can write. You can't just write divide by 2. What did you do? Multiply by 1/2. It's always multiply. So even though, yes, we did divide by 2, geometric always has to do with multiplying. Or you can do your 4 over 8, 2 over 4, 1 over 2. Those should all be equal because it tells you it is geometric. If it says it is geometric, you don't have to test them all. Just pick 2 that are next to each other. The bigger, the second or third divided by the previous. But if it said, is it geometric, then you have to test. All right, so A sub n equals, the first term is 2 times something to the n minus 1 times 2 times 2 times 2. So 2. Not 4 to the n minus 1. Okay, not the same. You cannot multiply before you raise that to the 2 to the n minus 1. Not the same. That is not 4 to the n minus 1. A sub n equals the first term times something to the n minus 1. Okay, for some of you, maybe not quite as easy as me, so 27 to -9, just do second divided by the first. And right there, you get -1/3. It's that easy if you need to write it down. So finding the common difference, second divided by first. If you have to see if there's continuing common difference, just keep doing that all the way until you run out of numbers. And then the last one is kind of like that problem you're given a little bit different information, so just plug in what you know. Well, we know the fifth term, so we know a sub 5, so we're going to say 16 over 27 is equal to, we don't know the first term, we know r is 2/3, and we know 16 over 27 is the fifth term minus 1. So the fifth term is going to be the n term. A sub n, a sub 5 in this case, n is equal to 5. So we end up with 16 over 27 equals a sub 1. 2 to the fourth is 16. 3 to the fourth, 81. Now, I don't know yet if your quiz or test will be a calculator. Like if we made this something bigger, like let's say we said this is the 12th term, and it'd be 12 minus 1, and you had to do something to the 11th. If those are the numbers that end up on the quiz, you'll have a calculator. Okay? If they're smaller, then you won't. I just don't know yet. But I will let you know in plenty of advance. All right, so 81 over 16. Multiply that on both sides because you can't divide fractions. You multiply by the reciprocal, so if you just do that right away, A1 equals 81 over 27 is 3. So my first term is 3. We need to find the first 3 terms. Since we're finding all 3, be sure and label it. Now, here when we were doing like the fourth term, a sub 4, I don't care if you say a sub 4 equals because it's the only one you're looking for. Obviously, I know that's your answer. But if you just have these random numbers boxed all over your paper, okay, and you don't have them assigned to something, just be sure that I know which one is which. Now, the way you find the next number in a sequence is once you find the common difference or ratio, you just apply that. So in this case, since we know the ratio is 2/3, we take 3 times 2/3 and we get our next number. We take 2 times 2/3 and we get our next number. So there are your first 3 terms. And you could keep doing that forever. Now, if I wanted to know the 23rd term, I would need to use the nth, the formula for the nth term. All right, so not too bad. Now, know that tomorrow we're